Clabberton. Welcome to Conversing.
I'm really thrilled this week that we have the opportunity to have as our guest on Conversing Dr. Jennifer Wiseman. Jennifer has been on Conversing before, but to remind those of you who have forgotten or to introduce her to those who may not yet know her, she's an astrophysicist, an author, and a speaker. She studies the process of star and planet formation in our galaxy using radio, optical, and infrared telescopes. She's also really interested in national science policy and public science engagement. She served as a U.S. Congressional Science Fellow, and she is the Director Emeritus of the Program of Dialogue on Science, Ethics, and Religion for the American Association for the Advancement of Science. Dr. Wiseman studied physics at MIT, co-discovering a comet named Wiseman's Skiff in 1987, and continued in astronomy with her doctoral research at Harvard. She's worked with several international observatories and is currently a senior astrophysicist at the NASA Goddard Space Flight Center. Jennifer, welcome. I'm so grateful that we can have this time together.
I'm grateful to join you.
You know, one of the things that is always mind-boggling to me is just your own journey. It's mind-boggling just because of, in my mind, it's not the expected journey. You were born in the Ozarks and you end up traveling from the Ozarks to the cosmos. So tell us a little bit about just that journey again, so that we understand how all that really unfolded. Less in terms of your jobs initially, but what was really happening for you as a person, discovering the things that you were doing and exploring the things that you were exploring.
This was not a planned, a life plan. Never. I grew up as a child on a farm in rural Arkansas, and really just enjoyed being outside in nature. I look back on it now and realize it was quite a privilege to be out on a farm where I could just wander around. We had livestock, but we also had some forests and streams and ponds and meadows and hills, and I could just wander around and explore. And I realize today when I tell people my story, most of them just don't have that kind of experience, sadly, that they either just have no place to do this, or if there is, it's not safe. They don't feel
right
altogether safe just wandering around day and night. So I'm really thankful that I had that experience, and I still enjoy it. I go back to that beloved place every time I can.
Yes.
But as far as formal science, I didn't know anything about that. We didn't live near any city that had a university at the time. My parents didn't have the opportunity to go to college themselves, but they made sure that their 4 children were able to. So I'm a first generation college grad in that sense, although my parents had 2 kids and then later on had 2 more, and I'm the last one. So I feel like they finally got it right. But the older pair were quite a bit older than I, and my older brother Michael first went off. He was the real pioneer and went off to college. He was brilliant and married a wonderful woman, Carol, and they, as I was growing up, they were married before I was born. So as I was growing up, they tried to encourage me to use my mind. They would always send me interesting puzzles or science gifts for Christmas or for my birthday, and so that was really great. So I got that kind of encouragement. But really, it was just more soaking in the natural world. I'm also a real lover of animals, all kinds of animals, wildlife, pets, livestock. I just treasure the animal world, and I got to kind of observe all 3 of these types of animals growing up and really bond with creatures and also just observe. So all of that kind of fed into me organically. And then I was also fortunate that my school, my little public school system there in northern Arkansas, was very good. I mean, we had dedicated teachers there who really committed themselves to valuing their students and to helping us learn and to build in us, I think, a healthy sense of confidence, so that when it came time to apply for colleges, of which, I had no experience, but they were behind us, and as I mentioned, my older brother, encouraged me to apply for places maybe outside the usual beaten path for students from my town. And then my parents, bless their hearts, they didn't really know what kinds of things I was applying for, but when I got admitted to a top university, they really sacrificed so that I could go. And so all of those things really opened doors for me. My high school guidance counselor was very encouraging, and I decided that I would major in a science in college, but I didn't know exactly what. But I'll say a couple more things, which is that growing up as I did, I was born in the 60s, but really was kind of growing up in the 70s and early 80s. There was a lot of interest in space, in the culture all around us. And
Yes.
I was, kind of on the tail end of the Apollo era. But I remember vaguely some of those images of the Apollo astronauts, driving around the buggy on the moon and that kind of thing.
Right.
But what really influenced me was after that, when the Voyager probes went through the solar system and for the first time sent back close-up pictures of the outer planets in our solar system and their moons.
Yes.
And I just thought this was the greatest thing humans had ever done, and I still do, actually. And so, these incredibly exotic worlds of Europa, let's say, these ice-covered moons, or Io, which is the opposite, is like a volcanic moon of Jupiter, and everything in between. And I thought, I have no idea how to do this, but I'd like to be a part of this enterprise. I don't know whether I should try to become an astronaut or try to be an engineer and build these probes, or try to be an astronomer, or try to be a cosmologist and understand the deep secrets of the universe, or what. But somehow I want to be involved in the space business, and I have no idea how. So when I went off into college, I ended up majoring in physics. I always liked physics in high school because it seemed like just a beautiful way of applying some very simple formulas in mathematics to understand everything that's going on everywhere, gravity, radiation, you name it, what's going on inside the atom. Now, of course, when I got to college, the physics was not so simple anymore. And I had a kind of rude awakening to that. And of course, my high school was great, but we didn't have a lot of the preparatory classes that the students from more privileged or, well-endowed cities and stuff had. So I'd never had any calculus or anything like that. And so showing up, the first day at MIT and in the first day of Physics 101, they put a simple calculus formula on the board, and I didn't even know what the little squiggly integral line was. I had a lot of catching up to do. So that will bring us, we can discuss later, but that can bring us to the topic of prayer, because I learned, all about humility and learning and asking God for help in the academic realm as well. And God was marvelously faithful. So that's a little bit of my background, as well as the encouragement I had from my church family growing up, which we can touch on too.
Let me just ask one more detail about your home and the location of it and the time outside in nature. You didn't mention a dark sky, but I'm assuming it had a dark sky. And if it did have a relatively dark sky, then how relevant at that stage in your development was the sky to your appreciation of nature?
Yes, that's a key component of everything I just described, because we could see plenty of stars at night out in this rural area. And my parents and I sometimes on nice weather nights, would just go for an evening stroll up and down the lane with our dogs. And, I would just look up and appreciate what I was seeing and try to correlate what I was seeing with my own eyes with what I was learning about from, like I mentioned, these images coming back from the Voyager probes and things. And, I would look up, in fact, I still do today, look up at some of these things in the night sky and say, well, wouldn't it be neat if I could just sort of blink my eyes and be there and, right in that environment and just have a close-up look at this or that object, not too close, but close enough to see. So yeah, seeing the night sky, there's nothing quite like that sense of awe that one feels if you can actually find yourself in a really dark place, especially when the moon is not shining. So when you have like a new moon, then the sky is really dark and the stars show up and you can see them from horizon to horizon. And very few people get this opportunity now, because even the smallest towns, even my hometown in Arkansas, now I go to that same farm, but the sky has a glow at night that's come up from just the town kind of sprawling out, and people put lights on the parking lots and lights on the streets. And what happens is that stray light bounces around the dust and the particles in the air and just creates an air glow. So it doesn't get as dark anymore, and you can't see as many stars, and you don't have that overwhelming sense of awe and humility. But there are still some places on the planet, for those who have the opportunity, where you can go, and if you intentionally try to find them and have that experience, and it's so worth it, because then you just realize what's out there in a kind of visceral, personal sense.
Right.
You can see the disk of our Milky Way. I mean, if you think about what is a galaxy is a collection of hundreds of billions of stars and a lot of gas and dust between those stars. And many of these galaxies are laid out in like a spiral pancake type shape. And we really believe that our own sun is one star and our Earth is just a little planet orbiting that one star. But we're part of one of these spiral flat galaxies. We can't get out of it far enough to take a picture of it. We can't take a selfie of our own galaxy. That would be great someday. But we know enough that we know we're kind of inside that plane of the galaxy. So when you look along the plane of the pancake, if you will, you see a lot of blended starlight just streaking across the night sky.
Yes.
And that's why it's called the Milky Way, because it's just this kind of whitish kind of cloud that crosses the night sky. And you realize you're actually looking through the plane of a spiral galaxy, our own. That's an amazing realization. And again, you need to be in a dark enough place to see that. And so it's hard for most people where they live to experience that. But if you can get out of the city lights areas, then you can have that experience, and it's pretty awe-inspiring. So yes, as part of my general love of the natural world, being able to see the night sky with my own eyes and kind of reflect on being a part of the universe viscerally was a part, I think, also of nurturing my interest. What I didn't do, which a lot of people who grow up to be astronomers do, is I didn't have my own telescope. I didn't fiddle with telescopes and lenses and cameras. So I really admire people who do that and who, grow up learning about different kinds of telescopes and how to play with them and nowadays you can have the very sophisticated telescopes. The word, quote unquote, amateur astronomy is these are really unpaid professionals now in these astronomy clubs and organizations who have, the quote unquote backyard telescopes, but they're very sophisticated now, where you can get what would have been, a decade or two ago, only professionals could have obtained, but they can get really great images of planets and nebulae and clusters of stars and record them, and of course hook them up now to laptop computers to quickly guide them to where you want to go and teach you things about the object you're seeing. So anyway, I didn't have all that gadgetry growing up, but I did appreciate looking at the night sky with my own eyes.
There was one other major thing that you had that was affecting your vision then, and I think now, which is your Christian faith, which was part of your formation as a child and continues to be part of your life. And how did that additional dimension of this cosmology, this cosmic reality, also being held in some sense by the God who made all things and holds all things together? How did all that interact as you were developing as a scientist?
I think the personal faith that I have and had as a child had an enormous role in how I thought about the natural world, looked at the natural world. We weren't taught in the church that I grew up in, we weren't, sort of channeled to very specific interpretations of the Bible that would impact very specific findings of science. But we were, very much assured that the universe, that all of creation is because of God, and God is responsible for the creation, and that the creation is good. And so I think that general joy that, we had a hymn we would sing growing up, "This is my Father's world," this beautiful hymn. And it even acknowledges that there's one passage in there that says, "And though the wrong seems oft so strong, God is the ruler yet." It kind of acknowledges that, there is some bad stuff in our world, very bad stuff. And yet ultimately everything is in God's hands. So, and then there are some other beautiful hymns about the creation and the beauty of nature that just kind of underscored that basic understanding that God is responsible for everything in the natural world and it's good. And I think that kind of enabled me to pursue a science and even a scientific career with a sense of joy that this is really a very natural outworking of faith. Because if you believe that God is responsible, is created for something, there's even some verses in the New Testament that hint that Jesus is upholding the universe, that kind of thing that you have to kind of, reflect on to try to figure out how you're going to understand that. But nevertheless, there's a clear sense in Scripture that the natural world is not something separate from God's interests or God's purview, that the natural world and life and all that supports life is something that God is responsible for and that God takes joy in. I mean, some of my favorite scriptures are buried deep in the latter chapters of Job or in some Psalms. I think Psalm 104 is one of them, but that really talk about I'll have to look that up, make sure I got that Psalm right, but that really talk about all the wondrous workings of the natural world, the mountains, the snow, the rain, the thunder, the birds, the different kinds of creatures. That it even says that God created some creatures in the ocean to just frolic there. They're not just there to be machines for us to manipulate and use and eat and unfortunately abuse. That in fact God did not create the animal world for that. He created the animal world to glorify him and to takes delight in them. So it's that basic foundation that I think. Also, I think growing up in my church community, we had a sense that we took the Bible very seriously. And even though we might read some of the passages, including the kind of opening verses of Genesis, which some people do struggle with, how do you relate that to a scientific view of the development of the universe? We took those verses fairly literally because we didn't have any reason not to. But we also were taught to be humble, that God may not have told us everything in Scripture, and that we need to keep that sense of humility and that God reveals truth to us in other ways too. And so I think that helped me a lot when as I became, more advanced in my graduate education and becoming an astrophysicist and understanding the enormous age and size and development of the universe, and realizing that some of the verses in scripture were never intended to give us all those details, that in fact God gave us the
Right.
gift of minds and the gift of science to understand some of those details. But it all harkens back to the greater message of scripture, which is that God is the author of the universe and the universe glorifies God. And we do well to study it well, and to study it in such a way that God is honored and that the people involved in the enterprise are doing this in a God-honoring way, and that we're using the knowledge that we gain to actually help people and serve others, and not in other ways. So that's some of the background of my church upbringing. We had a loving church family. It wasn't perfect. No church is perfect, but I'm thankful for the upbringing I got, with learning the basics of God's love and of the love of Jesus, and how important it is that we understand and have a relationship, that we understand who Jesus is, and have a relationship with Jesus. And that, of course, is something that grows and evolves throughout one's lifetime as we face different ages, different places, different challenges, different stages of life.
So fundamentally, there was a sense that faith and science were friendly neighbors and interconnected in some ways that didn't create a lot of tension or rivalry, or let alone animosity.
That's
Is
right.
that
Now,
roughly
but
true?
again, we didn't actually touch on the subject specifically very much. So I
Yes.
think in that sense, it was kind of good. I never was sort of put in a corner where I had to feel like I had to take a side on faith or science
Right.
or something like that.
Right.
It never occurred to me that these concepts were somehow could be seen as disparate concepts. And so I'm thankful
Right.
for that. Yeah.
Yes, absolutely. So you grow up, you keep developing. One big moment happens in college where you and another person discover a comet. Now, it's not every day I talk to a person who not only discovered a comet, but therefore has a comet named after them, as you do. But just take us for a moment into that discovery and what that was like for you.
Well, this was very unexpected. I did not expect this to happen, but I took advantage of some opportunities at my university where they allowed, they made opportunities for the undergraduate students to learn what scientists really do. In fact, we were encouraged to get involved in real research labs early on from our first year of college. But my senior year, there was a chance for interested students to take a field trip for a couple of weeks in January and go out to a real observatory to learn what real astronomers actually do. So we went to Lowell Observatory, which is in Arizona. It's famous because that's where Pluto was discovered.
Yes.
And thanks to the generosity of our professor from MIT, the late Jim Elliott, he patiently took students out every year to Lowell Observatory to learn what astronomers actually do. So I was in this cohort, and each one of us was kind of assigned to kind of shadow a professional astronomer out there. And so it was like my first day out there. I didn't know anything. And the astronomer, the late Ted Bowles, was very kind and gave me a task to learn, which was to look on these, what we call photographic plates. So at the time, this is in the late 80s. Okay, so this was before. Now, of course, telescopes are all connected to CCDs and electronic recording. But back then, it was kind of the tail end of the time when the way photographs of the deep universe were taken with telescopes was by putting photographic plates at the back of the telescope. And so as you opened the aperture and started collecting light, it would create an exposure and an image on a chemically coated glass plate. And so I was given the task of looking at a glass plate, which was a picture of the sky. It had a lot of stars. These are black and white images, but a lot of stars scattering the sky. But it wasn't the stars that was of interest to Dr. Bowl. It was what was in the foreground in our own solar system. He's interested in finding asteroids, and asteroids are little rocks, basically, that are orbiting the sun. And so he had me look at two different photographs of the same direction in the sky, but taken a few hours apart. And so the stars in a few hours don't move, but anything kind of in the foreground, like an asteroid orbiting the sun, would appear to move relative to those background stars. So we put those two plates in a machine called a blink comparator. And it's just kind of what it sounds like. It compares two pictures by kind of blinking between them. And you look through a little viewer, jumping back and forth between the two photographs, the two plates, and scanning them very tediously, one line at a time, and seeing if you see anything jump between the two photos that were taken a few hours apart. So I was scanning these photos and not seeing anything. It was supposed to be a field of asteroids, and I didn't find a single asteroid. I was failing at the entire task. But as I got down toward the bottom of this kind of tedious scanning task, I saw something else jump between the two images, and it was a more blobby thing with a kind of a long streaking tail. It looked like a comet and didn't look like the way a little asteroid dot was supposed to look. And so I went and found Dr. Bowl, and I said, look, I think I've seen something that doesn't look like what you showed me an asteroid would look like. It looks kind of like a comet. And I'm sure he was thinking, oh my gosh, how long do I have to keep working with this undergrad student for 2 more weeks? But he came out to the other building where I was, and he looked again. And then we took another machine. I mean, now you would do all this with computers, but we took another mechanical machine and measured the position on those glass plates of where this object was and how it had moved, so we could make a little estimate of where it was and how quickly it was moving. And it had been a few days since the pictures were taken. So then we wanted to see if we could find it again, to see if this was a real thing. And we went out back to the professional telescope, and the astronomer who actually took the images is still working at Lowell. His name is Brian Skiff. And so he went back and, based on these estimates, took some more pictures of the sky, and we found it again. And so it was real. Now, the long tail that looked like a comet, that really had nothing to do with the comet tail. That was the fact that it was moving so fast across the exposure that it kind of streaked across the exposure.
Got it. Uh-huh.
But nevertheless, this seemed like a real thing. And then we reported it up. There's actually a group in Cambridge, Massachusetts, that keeps track of all of these things in the solar system. It's called the Minor Planet Center. And so we sent this into the Minor Planet Center, and they confirmed that there wasn't any known asteroid or comet that should have been in those positions. And then they sent out a telegram around the world, and other astronomers, in particular from Japan, confirmed that they could also see this object. So then it became confirmed that this was a newly discovered comet. And I had nothing to do with naming it, but they have a convention of naming comets after the people who first detect them. And so the powers that be named it Comet Wiseman-Skiff after myself and Brian Skiff, who was the astronomer who took the photos of the sky on which the comet was discovered. So that's a long answer to your question. And then
Not everyone goes home from such a field trip with a comet named after them.
and I didn't know anything. I didn't know whether, are comets discovered every night, or are they discovered once a century, or what, and it turns out that there's about a dozen comets, more or less, discovered every year. Probably more now, because, as I mentioned, so many people around the world have more sophisticated telescopes that they can really scan the sky. Yes. But back then, there was about a dozen discovered every year. But most of them were on what you might call a parabolic orbit, or even a hyperbolic orbit, but an orbit where they basically make one pass into the inner solar system and then go back out to the outer solar system, and you never see them again. But some of them have periodic orbits, so they have a more elliptical orbit, and they come back regularly into the inner solar system where we can see them. And it turns out that the good news is that Comet Wiseman Skiff is a short period comet. It comes back every 6.5 years. The bad news is it's really dim. So the only people who ever see this every 6.5 years are people who have really professional quality telescopes. So I'm always hoping every 6.5 years, someone in the world finds Comet Wiseman Skiff again to make sure we don't lose it, because the orbital parameters can actually change a little bit every orbit.
I'm Mark Labberton. You're listening to Conversing.
There's an interesting postscript to the comet story, which is, it's actually a prescript, if there is such a thing. But again, this is my personal experience, but I was a senior undergraduate when this happened. And in my university, to graduate with a physics degree, you had to have written a senior research thesis. And I didn't even have a topic yet. It was January of my senior year, no topic. I have no topic, no thesis, no graduate. So, so I was actually praying for God to help me. I needed a thesis topic. I was kind of scared about the situation. And it was right about that time that this comet discovery happened. And then I ended up the rest of the semester studying that comet and writing a report about its composition and so forth for my senior thesis. Now, my prayers are not always answered in such a stellar fashion, but it is
indeed.
Interesting to me that for the rest of my life, that's been decades ago, I've done lots of other more formal astrophysical research and publication and so forth. But the story people most want to hear about is the comet, which was really a gift from God and helped set me off on a graduate career in astrophysics. So I think that there's something to learn from that.
Yeah. That's really lovely.
And then kind of on a humorous note, a few years later, scientists were looking at images from the rovers on Mars. And you're going to think, wait, this is a real non sequitur. What does this have to do? So the rovers that are on Mars, those robots that are driving around, taking pictures and so forth, some years ago, one of them was just taking a nominal set of images of the Martian sky and saw a streak, what we would call a meteor across the Martian sky. And so some scientists in Europe studied that image and studied the trajectory of that meteor that was basically a piece of rock burning up in the Martian atmosphere, and wrote a paper, a paper in the journal Nature that basically said they had determined that Martian meteor was a piece of debris from the tail of Comet Wiseman's skiff. So, so that's when I just think, wow, God has a sense of humor. So
that's
anyway,
great.
Yes.
Well, let's, as it were, scan out and go to the big projects that you've been engaged in, the observatories that you've been attached to. And particularly, I wonder if you could focus in on the work that you've been doing with the Hubble. Maybe you could describe that. And then what I'm interested in exploring is really what you would most want to draw to our attention about where the Hubble is in its own development, its ongoing development, which I know it has been in ongoing development over the years. And now with the addition of things like the James Webb Telescope, how do we understand the relationship between those two projects? There's many different observatories, many different telescopes that are doing such work. So let's just start first with your work through and with the Hubble.
So there are quite a few professional telescopes at work now in space and on the ground. I've had some experience with several of them, working with them, observing with them. I got my start using an array of radio telescopes that are out in New Mexico, the Very Large Array, which enable you to see into some of these dense clouds of gas and dust between stars and find where new stars are forming, that kind of thing. So that became the research I did for my doctoral work. I've also used different kinds of telescopes and worked in different professional capacities that use different kinds of telescopes. And one of them is the Hubble telescope, very famous. The Hubble Space Telescope has been orbiting the Earth for 34 years, but it's been refurbished time and time again by astronauts going up and putting on new cameras, new instruments, and so forth. So it's actually in really good shape right now, believe it or not, as are some other telescopes in space. And the newest large one is called the Webb Space Telescope. It is seeing different kinds of light than Hubble sees. So Webb is tuned to look at infrared light, whereas Hubble sees a little bit into the infrared part of what we call the broader rainbow, the broader electromagnetic spectrum. But Hubble is used mostly nowadays for looking at visible light, like our eyes could see, and the bluer than blue ultraviolet light. So these two observatories complement each other in great ways, and it was kind of by design. So the Webb telescope was designed to see these infrared wavelengths of light that allow you to see in our own galaxy and nearby universe. You can see into some of these dense, dusty regions where stars are forming, or even right around some of these young stars where planets are forming. So these star-forming regions and these planet-forming zones right around stars where there's often a dense disk of dusty material out of which planets are coalescing. Webb is really able to peer into some of these regions in complement with a large array of radio telescopes in South America that's called the ALMA, the Atacama Large Millimeter and Submillimeter Array, which sees radio wavelengths in what we call millimeter and submillimeter wavelength regimes. These types of facilities see into these regions that are shrouded from visible view. Webb is also designed to see reddened light from very distant galaxies. So galaxies are collections of hundreds of billions of stars and a lot of gas and dust between those stars. And in early galaxies, early in the universe, as the universe was just getting going, there was a lot of activity in these first little gravitationally bound conglomerations of gas and the first stars forming out of them. And those early galaxies often would radiate in this energetic ultraviolet light. But the universe has been expanding now since the beginning of the universe, which we think was about 13.8 billion years ago. And we're seeing some of these infant galaxies as they were from well within that first 0.8 of the 13.8 billion years. And as the light from those early energetic galaxies started moving across the universe, which is expanding, moving across stretching space reddens light. And so now in our epoch of time, I know this is a little mind-blowing, but as we are looking at some of these very distant and therefore very early galaxies, because we're seeing them as they were when the light began its trek to us, that light has been stretched into the redder and even infrared wavelengths that only the Webb telescope can pick up for the most distant ones. So that's why Webb was designed to actually be able to see some of the infant galaxies that are just a couple of 100 million years old, which sounds old, but in a universe of 13.8 billion years, that's pretty early on in the universe. And that meshes with what Hubble can see from galaxies a little bit closer that are not, the light is not quite as shifted into those infrared wavelengths, but because they're closer, some of them we can see much more detail with Hubble, so we can kind of see what goes on along, let's say, the spiral arms of some of these galaxies as stars are forming, and then we can extrapolate what that would look like back in the early universe where Webb is looking. So that's a long way of saying that these two particular space observatories are both very powerful, very much needed, and very complementary right now. But they're also complementing other observatories in space. We have like the Chandra X-ray Observatory. We have a whole slew of smaller space telescopes that were designed for specific purposes, like to look for exoplanets, planets around other stars or things like that. And observatories on the ground, such as these radio arrays that I've mentioned to you, and other large optical telescopes and infrared telescopes that can do some things from the ground. And so astronomers tend to use a combination of these platforms to study whatever it is they want to learn about, whether it's planets in our own solar system, or whether it's other stars or their planets or distant galaxies. And depending on the type of astrophysical question one is asking, you choose a certain type of telescope that sees a certain wavelength of light or sees a certain field of view in the sky. And it's these facilities working in concert that really give us the richer, deeper picture of the universe that we want to have.
One of the things that's always fascinated me about astrophysics is that there's such a sense of its ongoing development. That seems like a silly thing to say, except that as a non-astrophysicist, it's easy to just think all these things are fixed and everybody's seeing them and we're seeing them clearly, at least to the degree that our technology allows us to do so. And then along comes some major discovery when you think you thought it was this kind of universe, and then it just turns out to be this other kind of universe, or that this particular thing that we thought we knew in the sky was one thing, and then it just turns out to be something very, very different. So a recent example that caught, I think, my attention and probably the attention of a lot of people was this discovery of a quasar, which had been understood to be a star and relatively close to us, when in fact it was much, much, much more distant from us and was actually a quasar and has been labeled the brightest thing in the universe. So just talk to us about that kind of discovery and what that means. This, I realize, may not be your specific focus of attention, but it certainly grabs headlines.
Sure. So, well, first of all, let me just address your first framing there, that often we see something in astronomy that's different than what we expected, and it changes our view of something fundamental. And for astronomers and astrophysicists and science geeks, I'll say, this is wonderful. We love to hear a story where, we thought this all these years, but now this new observation just throws that theory into uncertainty, and we think now it's that, and we say, wow, isn't that cool? Isn't science progressing and doing just what it's supposed to do? But I've noticed that for a lot of people who are not, buried into these enterprises, when they hear things like that, they sometimes think, wow, these guys are idiots. They thought this other thing all this long, and, why should I believe them about anything? Because, they're always being proved wrong.
That's not where I was going.
Exactly. So that there's a different perception. So when you hear these science headlines like, wow, scientists were very surprised by this, that, and the other, I encourage you to take that as a great thing. That means that science is working. It doesn't mean that, everybody was completely wrong about everything and you shouldn't believe anything scientists say. It's like, no, scientists make progress, and the new discoveries are actually critically based on the foundational knowledge that led up to that.
Yes.
So in terms of a quasar, what exactly is a quasar? A quasar is actually the core of a galaxy. So remember I mentioned that a galaxy is a collection of hundreds of billions of stars and all the kind of gaseous nebulae between those stars and a whole lot of unseen dark matter, but we know it's there because we can see its gravitational effects. So we live in a galaxy. Our sun is in the Milky Way. In the cores of galaxies, right in the middle of them, there seems to be a repository of old stars that have died out. And while stars are typically orbiting around, the galaxy's rotating and stars are kind of orbiting around within that galaxy, but there's a little friction, and eventually old stars kind of spiral in and migrate toward the center. And gravity in the center, basically, which pulls all matter together, classical gravity anyway. Gravity will make the centers of galaxies a very dense region, because this repository of old stars and other mass will come together and be compressed by the powerful, mutual gravity of all this material into ever increasing tight, small volume, a small volume. And there is a threshold over which, if there's enough matter within a small enough volume, the gravitational field is enormous, so much so that even light cannot escape the distorted space. Einstein basically said that matter distorts space, that gravity is actually really a distortion of space-time, and all matter distorts space-time. You and I are distorting space-time, just not very much. But in the cores of galaxies, that amount of mass compacted into such a small volume can create an enormous, what we call a black hole, one of these regions where the space is so distorted that even light cannot escape, and material that gets too close will fall in and cannot escape. It appears that now most galaxies have a supermassive black hole at their cores. Even our own Milky Way seems, as you look at the motions of stars kind of orbiting around the center of the black hole, you can do a pretty simple calculation that the speeds of those stars are very fast, and that implies that they are trying to not fall into something very massive. But there are galaxies, in particular in the early universe, where those supermassive black holes are even orders of magnitude more massive than what we have in our Milky Way. And they are so massive that they are accreting a lot of surrounding stars and gas and just gobbling it up. And as that material falls into what we call an accretion disk around the black hole as it's spiraling in, it can create these enormous expulsions of light and even outflowing jets. That's because some of the material gets caught up in magnetic fields and ejected. Some of those galaxies that are experiencing this in the early universe are very bright. The cores, these centers, the black holes in the centers of these galaxies that are accreting material are doing so at such an energetic pace that they are releasing light, not from the black hole itself, but from that accretion region around it at an enormous brightness. And so that's what a quasar is. We're seeing the core of an early galaxy that's got a supermassive black hole that's really gobbling up some of the massive early stars from that galaxy. And they really are the brightest things in the universe. The core of these galaxies can be brighter than the rest of the whole galaxy in which they sit. So what's been seen now is the brightest one of these that's ever been seen. And it was, as you say, I believe first thought that it was actually a closer star or object, but now we find that it's actually one of these distant quasars, and it is phenomenal that we know both what these things are, and we can now, do a more accurate estimate of their distance. In this case, it looks like, remember when I mentioned to you that we think the universe is 13.8 billion years old, and we're seeing some infant galaxies kind of within the early parts, shining from within the early parts of that history. Well, this one appears to be shining to us from 12 billion years ago. So we're really seeing it from a very distant time in both time and space.
And in the report I read, it said that it's mind-boggling that its brilliance is 500 trillion times more intense than the sun.
Yeah. Just try to wrap your head around that.
Even for you, is that hard to wrap your head around?
It is. In fact, it just doesn't make a lot of sense to us when we use these astronomical numbers. But it is something that we have to grapple with. There are things in the universe going on that are very different from what we experience in our day-to-day life, or even in our own galaxy. We have a fabulous galaxy, but it doesn't have anything like that going on right now. Right. And I try to imagine, what would it be like if you were in that galaxy that hosted that quasar at its core? Let's say you were safely enough away from the core that you could exist, but would you even be aware of this as you look toward the center of your own galaxy, and what would it look like? And, you just try to imagine that kind of thing.
Well, let's take something that's a little more approachable and that many, many people, even just a few weeks from now, are going to be taking full advantage of. And you yourself and your extended family, I think, are going to be taking full advantage, which is a solar eclipse that's about to happen in the early days of April. So tell us about that, and any comments that you'd like to say to people who are within the band, who are going to be able to see it, at least if weather permits. They're going to be able to see it pretty dramatically. And then for others of us who are not really within that bandwidth, what should we anticipate?
It's going to be a spectacular experience and opportunity. So this is happening on April the 8th this year, which is 2024 as I'm speaking. And if you can find your way to the path of totality, that's the path where the moon will pass completely in front of the sun. This happens in the middle of the day. So the moon, is doing its own happy little orbit around the earth, and the earth is doing its own little happy orbit around the sun. But every once in a while, these things align such that from our vantage point, the moon passes in front of the sun and can block out the sunlight. So that's what we're talking about here is an eclipse. And this year's eclipse is going to pass through North America, including Mexico, the United States, and parts of Canada, through a particular strip that kind of comes up through Mexico, Texas, Arkansas, Missouri, Illinois, and then up toward New England, and then up into Canada. You can find a map. I mean, it's easy to just use a search engine and say, eclipse 2024 path or something, and you can find out exactly where you can find a place to go to see the total eclipse where the sun is completely blocked out by the moon. And if you're in that path, this will last. Well, the eclipse lasts usually a couple of hours because it takes some time as the moon begins to pass in front of the sun. And then the complete coverage, totality, takes usually a few minutes, something like 3 minutes, depending on exactly where you are. And then it takes about an hour for the moon to kind of appear to slide off the front of the sun. It's a fantastic experience. If you're in totality and it's not cloudy, the first leading up to it is very interesting to watch as the moon passes, over more and more of the sun. And then during totality, it is dark. The place, the natural world around you grows dark because it's night. There's no sunlight, it appears, except not completely, because there are the corona, the outer atmosphere of the sun, is peeking out around the edges of the moon. And that's the neatest part of the eclipse, because at that point you can safely take off your safety glasses, which I'll say a little bit more about, and view with your own eyes the corona of the sun and the activity of the sun. And it is, for many people, a spiritual experience. The birds get quiet and night birds come out. The animals act strange. It's good to be out in a place of natural beauty where you can kind of see and hear some of the changes in the birds and the wildlife. There's an eerie glow all around the horizon of Earth because of some of the reflections coming off from the deep horizon, and then the oohs and ahs of the people around. It's an experience where, one of those rare times when people on Earth are not fighting with each other, but they are united in looking up and realizing that we're part of something awesome. Also, This is an unusual year. This won't happen in North America for another 20 years. So it's really kind of a once-in-a-generation experience for us here in North America. But the sun itself goes through a cycle of activity that goes about every 11 years. So some years it's very active with these coronal ejections and things like that. And then some years it's pretty quiet in terms of the activity on the surface of the sun. Well, we are in a peak of solar activity now. So if you can see the corona, the outer layer of the sun during the eclipse, as the moon covers the main body of the sun, you can see this outer corona and activity, which, really you'll never really get that chance much again with your own eyes. Now, all of that said, there are some caveats. A, you should never look at the sun unless you have, even if it's 99% eclipsed, you still need to use a special kind of solar viewing glasses. They're not hard to find, but you just need to make sure they have the special rating for safe viewing of the sun, because you will fry your eye out if you stare at the sun. So you want to make sure you have safe eclipse glasses for looking at the sun. The standard is ISO 12312-2. So when you're looking online to try to buy some of these glasses, they're not expensive, but make sure they say ISO 12312-2. And if you forget that number, you can, look that up. What is the safety rating that I need for my eclipse glasses? And you'll find it out. So get your eclipse glasses ahead of time. They can be just a little paper with the special filter, and use them when you're looking at the sun. Except if you happen to be in those 2 or 3 minutes of totality, you can take them off. Secondly, it may be cloudy for people who are even in the path of the eclipse. And so be prepared for that. That's a bummer, but you can still experience that sense of darkness, and also watch online, because there's going to be all kinds of live coverage from NASA and everywhere else of the eclipse from different vantage points. So it'll be basically a continent-wide party that day. So from wherever you are in the nation, you can join that online party. And thirdly, from most everywhere in North America, you will be able to experience a partial eclipse. So you'll need those solar glasses to see that, but you can at least see with those special glasses the moon moving over part of the sun, and that's really cool as well. So I hope everyone gets something out of this eclipse coming up. You can also you can look online, have these little box viewers where you're not looking up at the sun at all. You're letting the sunlight come down through a little pinhole viewer, and then it shows the shadow of the moon passing over the sun on a little piece of paper you can put below you. So that's another way of experiencing this. Everyone can experience the eclipse in some way, even if it's just watching it online and enjoying the continental-wide party that day. And I hope this really is a kind of spiritual experience where people reflect again on the universe we live in, what a privilege it is to be alive and to be on this planet, and how united we are. We really are all fellow earthlings, and just having that one day to kind of appreciate this kind of imposed on us by the workings of nature, I think is a great gift.
It is a great gift. One of the things that has happened to me over the years has been that I've had many, many important experiences, I would say, with the moon. So this has happened since I was a child through adulthood, different parts of the globe, different places, different night times, different reasons that I've been in those settings. And the affinity that I feel toward the moon is a very significant one because of all of those memories. And so when an event like this comes along, where the moon actually gets blackened out, or blackens out rather, the sun itself, it's just going to be an exquisite experience. So thank you for sharing that with us. Jennifer, I'm just curious, as we conclude our conversation, there are so many things that are going on the planet Earth that are troubling. Are there things in space? I mean, I just choose one of these, but I'm throwing out a few that come to my mind. Two of the most noteworthy have been, frankly, space junk that we have put up in our explorations that seems to be floating around in the Earth's atmosphere or just beyond it in some way or another. And the other is the question of the commercialization of the moon or of other planets, and the questions of, after all, who owns these things, who gets a say in whether they get, quote, developed, like we might a parking lot in Milwaukee, as it were. How should we be thinking about these things from your point of view? Either one.
Well, human beings carry with us all the good and the bad that we carry with us on planet Earth when we go off of Earth. This should not be a surprise, but sometimes it's a disappointment because we've all watched a lot of science fiction where, maybe you can go to some utopian planet and they don't have all the problems that we have on Earth, and we could all learn from them and live happily ever after. But wherever we go, we tend to, bring with us human tendencies. So in a good sense, exploration and curiosity, I think, are very good human tendencies and gifts that we should nurture. So that's why I think astronomy and astrophysics is a wonderful human enterprise, even though it doesn't have any commercial practical benefits, but it lifts the human spirit. I have a colleague who is a Christian who has spent some of her vacation time at orphanages in parts of the world where the children have had traumatic experiences as children. They've lost their parents, sometimes from violence, and they have enough food and clothing. What the children want to hear from my colleague is about space. They want to know, what we're learning with our telescopes. They want to become astronauts. The human spirit longs for uplifting things to learn, whether it's science or space or even, literature,
Yes.
music, those kinds of things. So we bring that with us when we explore space. And I like that part. We also bring our carelessness and I think possibly even our evil with us, or could. And carelessness means the space debris. We have so much junk now that's orbiting the Earth that's left over from previous missions or collisions between satellites or all this kind of thing. And nobody wants to pay for scooping this stuff up. That's not as glamorous as putting a new thing in space. So, this is a growing problem. And then we have intentional things, satellites in space that do good things, communication satellites, but we're putting them up by the tens of thousands. And that's creating problems for astronomy because, especially from the ground, looking up now for a sensitive image of the night sky, you're almost always polluted by some satellite that's crossing over your exposure, and that creates a problem. So how do you decide, which is more important, keeping a pristine night sky for science or providing, internet capability for people in remote places around the world? These are both laudable goals, but we need to figure out how to compromise on what we put in space, how to keep the space debris from an unbearable growing problem. And then, of course, there's the question of, militarizing space, and that we've, as humanity, we've kind of managed for the most part to stave off through treaties and things, but that has to be perpetually recommitted to in an international sense. And then you ask the question about, well, what about, when we go back to the moon and onto Mars, and the activities that are done there can be seen in one sphere as very, very good, and to others that same activity could be seen as very bad. Let's say mining resources. In one sense, this is a great use of these objects in our solar system to mine the resources that might be used to help support a colony there or to help make rocket fuel for even more distant space travel, and in a much less expensive way than trying to launch this material off the surface of the Earth. So that could be seen as great. Might even have some commercial value. So that could be good. On the other hand, that same activity could be seen in other cultural perspectives as very damaging to something that's sacred. The moon really doesn't belong to anyone, does it? So who has the right to decide to build a village there or mine resources or even do commercial activity on the moon, which for some cultures is a very sacred place. And for all of us, I think we love the pristine nature of the moon. So I think there's a lot of ethical decisions that still need to be made. And there are some people thinking about this. The question is, what will the nations of the world agree to abide by? And who gets to have a voice? What peoples on the planet get to have a say on how we use our space resources and the neighboring space bodies? So you asked the right question, but we have not yet arrived at unified answers as Earthlings.
Jennifer, one of the things that I love about getting to talk to you is that you help me to do one of the things the Bible exhorts many, many times, which is just to behold. And we're to behold many things. And we live in cultures around the world, which currently seem to be planet bound. And that for good reason, understandable reasons, but also problematic reasons. And what, of course, your very work and the technology that you're able to use and the commitments of learning that you're given to are all about helping us to behold what is beyond the horizon. And I just want to say, on behalf of the American people and myself, thank you for doing the work that you're doing. And thank you for the teams of people that you lead and that are helping to do this kind of work, because the scientific enterprise in general is so important in beholding the world that God has made. But the scientific enterprise related to space and the cosmos is one that, as you say, can be more done now than it has ever been done by amateurs. But principally, I would imagine, is still largely in the hands of professionals. So I just want to say thank you, thank you, thank you. And it lifts our gaze and it helps us to behold so much that we simply would not be able to see or know or understand at all, even though we may feel as though we're still so partial in our knowledge. It's the case that we have come so far, and I'm just really grateful for the way that you're helping to extend that knowledge.
Thank you, Mark. I totally agree that we, as human beings, need to take more time to just reflect on what we're seeing through our various tools, both on the large scale and also on the small scale.
Yes.
And, the internet creates lots of problems, but one thing that it does do is it allows fairly easy access for anybody who doesn't necessarily get to, climb the mountain and go to a telescope, much less go into space. But we can see a lot of these images from astronomy freely and easily on the internet. Take some time to do that. But my favorite kind of exploration is just taking time to go out in nature, even if that's just walking down the street or to the local park or sitting in your backyard, but just paying attention, just putting the phone away, putting the internet away, putting the social media away, and just watch for what you don't expect. What's that grasshopper doing? What is that? What are those birds doing? What's that bird so upset about over in that tree? And then watching the stars come out at night and just taking that time. I hope we all intentionally do more of that.
Jennifer, thank you so much.
Thank you.
Thank you for listening. Subscribe to Conversing on your favorite podcast app to listen to new episodes as they are released. And please leave a review. Conversing is produced by Peter Laberton and distributed by Fuller Studio.